Good morning. We start out this morning in space. 160 miles up high above California, Columbia's astronauts are ready to return to Earth. Nature did not cooperate with initial plans to land in Florida at 9:03 a.m. Eastern.
So, NASA has diverted Columbia to the California landing site at Edwards Air Force Base because of foul weather at the Kennedy Space Center. We're looking at a live picture of Edwards where the sun has just come up. Daylight just arrived. Touchdown at Edwards set for 10:30 a.m. Eastern Time, about 90 minutes later than first planned, an hour from now. And CNN plans live coverage.
And mechanical systems officer is watching that fairly closely. All three hydraulic systems, however, are working and operating properly in terms of their turbine speed at this point. And he's reporting to Flight Director Wayne Hale right now that it's very stable pressure above any of the limits at this point, so it appears to have stabilized and be in good shape. We're about 39 minutes away from landing of Columbia and about 7.5 minutes away from entry interface, a point at which Columbia begins interacting with the Earth's atmosphere. At this point in the entry, the guidance, navigation, and flight control software for entry is initiated by the crew, and the digital autopilot aboard Columbia begins responding to commands, both automatic or manual, and the sensors that indicate the orientation of the orbiter. The reaction control system jets are also commanded, as are the actuators for the flight control surfaces, which are the movable surfaces on the wings and tail of the orbiter. Columbia is presently traveling about 16,500 miles per hour. And now just descending through about 490,000 feet. We're a little under 3 minutes from entry interface, the point at which Columbia begins passing into the Earth's atmosphere. Columbia has just descended through 400,000 feet. Current velocity is 16,500 miles per hour. This is known as the entry interface portion of the flight. Range from the touchdown or range from the landing site's about 4,290 nautical miles. At this point, Columbia is maneuvered to 0 degrees roll and yaw, which is basically wings level with the nose pitched up about 40 degrees. Also at this point, the flight control system software issues commands to the thruster jets, the reaction control system jets, to begin damping the rates for entry into the atmosphere. As Columbia begins moving into the atmosphere, the movable surfaces on the wings and tail become active in stages, and as they become active, those portions of the reaction control system jets that correspond to those surfaces are deactivated. The range from the landing site for Columbia is 3,600 nautical miles. Current altitude is 310,000 feet. The crew transport vehicle awaiting Columbia's arrival will transport the crew from the spacecraft to the medical facilities at Dryden Flight Research Facility for routine post-landing medical checkups. This is Mission Control Houston. We lost data with Columbia for just a few minutes. And we now have the data back. Columbia is 2,380 miles from the landing site at an altitude of 239,000 feet.
Columbia, Houston, we're experiencing a little comm and data dropouts. We're back with you now.
Roger, loud and clear.
The guidance aboard Columbia has initiated the first roll command to the left. The orbiter is now making a wide banking turn to the left to begin dissipating the energy that was built up during the launch phase. Columbia's speed is now 15,300 miles per hour. Altitude is 233,000 feet. Range from Edwards, 2,000 nautical miles. All systems aboard Columbia continue to perform well, and it's very quiet here in the flight control room and aboard the vehicle. The mechanical systems officer reports that all three hydraulic systems are stable at this time. Good cooling. He sees good cooling on all three systems. Guidance officer reports he sees typical the drag profile on the orbiter. Columbia's speed is 14,400 miles per hour. Range from landing site is 1,600 nautical miles. Current altitude is 224,000 feet. Time to touchdown, 19 minutes. Columbia is continuing to bank toward the left to assist in dissipating speed from the orbiter. Present speed is 12,700 miles per hour, altitude 208,000 feet. Range from the landing site is 1,070 nautical miles. The next roll reversal, as it's called, will be from the left to the right, and that will be initiated at about 7,000 miles per hour. Just under 16 minutes from touchdown. Guidance Navigation and Control Officer reports that the series of program test inputs has been initiated aboard the orbiter. These are small movements of the surfaces, movable surfaces on the wings and tail. These PTIs, as they're known, are designed to assist in generating new data on the orbiter's ability, landing weight, and for normal end of missions to expand the database of knowledge of the orbiter fleet during the landing phase. Columbia is descending through 182,000 feet, traveling 9,800 miles per hour. Range from the Edwards facility, 626 nautical miles. Columbia's range to the landing site is 460 nautical miles. Altitude 168,000 feet. Coming up on initiation of the first roll reversal, that will be a wide sweeping turn from to right to continue the landing profile and deceleration of the orbiter's speed.
Columbia, Houston, you have a go for the body flap sweep.
Roger. Body.
Columbia Houston, energy, ground track, and nav are all go.
Roger, thank you.
Columbia continues on the proper course. Altitude 158,000 feet. Time to touchdown 11 minutes. Range from the Edwards facility 345 nautical miles. Columbia's speed is 6,400 miles per hour. All systems continue to perform well aboard the orbiter.
Columbia Houston, take TACANs.
Take TACAN.
Time to touchdown 9 minutes 45 seconds. The crew is now updating the onboard systems with data received from the landing site. Range from Edwards 224 nautical miles. Orbiter speed 4,700 miles per hour. First views of Columbia from long-range cameras at Vandenberg as Columbia descends through 130,000 feet. The main engines aboard Columbia have been repositioned in preparation for the landing. The second roll reversal from right to left has been initiated. Columbia speed 3,800 miles per hour. Time to touchdown 8 minutes 30 seconds. Columbia is now 100 nautical miles from the landing site. Current altitude is 99,000 feet. Speed is 2,500 miles per hour. Time to touchdown 7 minutes.
Columbia Houston, take air data.
Roger, take air data.
Onboard systems now taking real-time data through air data probes in the mounted on the orbiter's nose. Columbia is approaching 2,000 miles per hour, and the point at which it would conduct the final roll reversal from left to right. One last wide sweeping turn around the runway will set Columbia up for final approach. Altitude 83,000 feet.
Columbia, Houston, with an update to winds and weather. We have 12,000 scattered, 15,000 thin broken, 25,000 thin broken. Altimeter is 29er, 9er, 8, and the winds are 220 at 12, peaked to 17.
Roger, 29er, 9er, 8.
Columbia, Houston, no action on APU-1 message. It's a repeat of the previous messages.
Copy that.
Guidance, Navigation, and Control Officer reports all of the program test inputs complete aboard Columbia. The orbiter is traveling 1,100 miles per hour. Range from the landing site area, 39 nautical miles. Time to touchdown, 4 minutes, 45 seconds.
Columbia, Houston, we show you on energy approaching the hack, and you are go for a nominal drag chute deploy.
Roger, nominal.
Commander Steve Nagel now flying Columbia manually. The orbiter is at an altitude of 38,500 feet. Range 20 nautical miles.
Columbia, Houston, on energy at the 90.
Roger.
Columbia is now making a wide sweeping turn around a heading alignment circle to set up for final approach to runway 22. The altitude is 14,000 feet. Columbia now setting up for final approach. Range from the landing site 7 miles. Time to touchdown 1 minute 30 seconds.
Columbia, Houston, on glide slope, slightly left of center line. Winds, surface winds are unchanged.
Roger.
Processing data through the microwave landing system at the facility. Altitude is 4,300 feet. Range 2 nautical miles. Landing gear is down and locked. Main gear touchdown. And nose gear touchdown. Columbia rolling out on runway 22 at Edwards Air Force Base in California on the 160th orbit of the mission after traveling 4.1 million miles.
Full stop, Houston.
Roger, Willkommen zu Hause, Columbia. Congratulations on a very successful international mission. There's a lot of folks all around the world that are very excited about the knowledge gained during your mission. Congratulations.
Feeling back.
Columbia, Houston, you have a go for post-landing. There are no deltas to post-landing.
Okay, we're picking it up on base 5-3.
Roger, copy that.
Spacecraft communicator Kurt Brown here in Mission Control, notifying the crew there are no landing deltas to their normal post-landing procedures.
Fill up clear also. Columbia, ET doors coming open.
Roger, Columbia, we'll be watching, and there will be no hydraulic load test today.
Copy, no hydraulic load test. At Houston, Columbia, the RJDs are off, side hatch, drag chute, and the gear are safe.
This is Mission Control Houston with unofficial landing times for Columbia and the STS-55 mission. The main gear touchdown of the orbiter was at 10:29 and 59 seconds Eastern Time.
We copy standby 1.
Or 9 days, 23 hours, 39 minutes, 59 seconds. Nose gear touchdown occurred at 10:30 and 18 seconds, or 9 days, 23 hours, 40 minutes, 18 seconds. And wheel stop was reported at 10:30 and 59 seconds, or a mission elapsed time of 9 days, 23 hours, 40 minutes, 59 seconds.
To the inbat.
Copy, thank you.
Columbia's crew up on the flight deck going through normal routine post-landing procedures, safing the orbiter, putting it in a proper configuration so that the convoy team can then move in and the crew can then get out of the orbiter and conduct their routine post-flight medical checks before returning to Houston later today.
Columbia, Houston for Steve.
Go ahead.
Yes, Steve, we're ready for ammonia activation, page 5-8, and we'd like to use the controller Alpha Pri GPC.
Okay, we'll use the procedures for Alpha Pri GPC.
Columbia, Houston for Tom.
Go ahead.
Yeah, Tom, today for SSME repositioning, we'd like position 02, the rain drain position.
Copy, the rain drain for SSME repositioning.
Good copy.
Pilot Tom Hendricks given a go to reposition the orbiter's main engines. This rain drain position prevents any water accumulation in the engine bells should that occur while the orbiter is in preparation for return to Florida.
And Houston, Columbia, ammonia A is now to Pri GPC.
Okay, Steve, thank you. And Columbia, Houston, for Steve, the evap out T's are expected.
Roger. Columbia, we go for AP shutdown.
Columbia, Houston, for Tom, you have a go for APU shutdown.
Shutdown APUs.
All hydraulic system duties aboard the orbiter are complete, and pilot Tom Hendricks has just shut down the 3 hydraulic systems.
Houston, Columbia, APUs are shut down.
Columbia, Houston, we copy that. We showed a good shutdown, and we showed the environment around the orbiter is good, and you have a go for doffing your suits if you like.
Roger, thank you. Houston, Columbia, we go for vent door purge positioning.
Columbia, Houston, for Tom, you have a go for vent door purge positioning.
Thank you.
Columbia, Houston, we have a switch throw on R7 when someone's able.
Go ahead.
Yeah, we would like you to select on the rotary, top rotary, we would like to select subsystem, inverter, input, amps, and give us a reading on what that is.
Zero 13, Houston.
Columbia, we copy 013, and that's nominal. Thanks.
Okay, and I'm starting into PCS deactivation.
And you have a go for that, Steve? Columbia, Houston, you have a go for extended power up, and concerning the RCS ohms valve test, we have no deltas to the test.
Okay, no deltas to the RCS ohms valve test, and a go for extended power up, Kurt. Thanks. Houston, for the CDR on page 5-14. If you like our NBAT, we'll go to 901 on GPC 1 only.
Columbia Houston, for Steve, we show a good NBAT, and you have a go for Ops 901.
Thanks, sir.
The convoy team moving in place around Columbia as the crew continues through the post-landing procedures, safing the orbiter and preparation for turning it over to the convoy team.
Houston, call me verify. We'll go for the Ford RCS manifold about depth.
Columbia Houston, you have a go for the Ford RCS.
Thank you.
Crew transport vehicle that will transport the crew members from the orbiter to the medical facility for routine post-flight medical exams, moving into place around the orbiter's crew hatch. There are two of these vehicles, one in California at Dryden and one in Florida at the Kennedy Space Center.
Columbia Houston, we'd like you to check your 4 ADTAs on the overhead panels. Those should be open.
Copy, Houston, open the ADTA circuit breakers.
Tom, that's a good copy. And for Steve, we want to make sure before you get off a comm that we have a good comm check with the ASP.
Okay, Kurt, I'm going to stay on comm.
Okay, we copy. Columbia Houston for Tom.
Go ahead, Houston.
Yeah, Tom, we'd like, if you could, check the Ford RCS manifolds 1, 2, 3, and 4 to open, talkback open.
Okay, we'll leave the Ford RCS manifolds open.
And that's a good copy, Tom. Columbia Houston for Tom.
Go ahead.
Well, actually, Columbia Houston for Steve. I'll get the other side there.
Roger, go ahead.
Yeah, Steve, just heads up, we're getting close to switching from ammonia A to ammonia B, and when you do that, we'll have to do some rad steps, which you probably know about already, but just a heads up on that.
Hey, that's okay. Just read them to me if you would.
Okay, we'll do that when we get there.
Okay.
Columbia Houston for Steve. Yes, Steve, we're getting ready to establish ground cooling. We'd like you to perform the ammonia deactivation on 5-22.
Okay, 5-22, that's in work. Okay, Houston, ammonia is off now.
Okay, Steve, we copy.
And Houston, the evap out temps are getting a little high.
Columbia, Steve, we're watching that, and we're getting ground cooling at this time.
Roger.
Columbia, Houston for Steve.
Go ahead, Kurt.
Yes, Steve, we need to go man rad flow on the loop number 2, and I got the steps calling out if you want me to do that.
Okay, go ahead.
Okay, rad bypass valve mode number 2 to man.
It is already.
Okay, and rad bypass valve man select rad flow.
Okay, rad flow and talkback says rad.
Okay, that's good. That takes care of it. Thanks.
Okay, fine. And Jim Halsell is climbing on board, and I'll be signing off in just a minute.
Okay, we'll be waiting to hear from him.
It'll be another minute or so.
Columbia, Houston for Steve.
Go ahead, Kurt.
Yes, Steve, we are go now for deactivation of the Space Lab water loop. If we can do that, or if we need to wait for Jim to get ready, he can do it, I reckon.
Okay, Jim is in here now and on comms, so you can read those steps to him, and I'm signing off, Kurt. Thanks for the great job for the whole team. We enjoyed it very much.
Steve, we copy, and it's been a pleasure working with you.
I'm at R7. Go ahead with your switches.
Okay, on panel R7, Jim, we need the avionics fan number 1 to off.
Okay, that's avionics fan number 1 to off.
Good copy.
This is Mission Control Houston. All 7 crew members of the STS-55 mission are out of the orbiter now and in the crew transport vehicle. They will undergo routine medical checkups before boarding NASA shuttle training aircraft, the modified Gulfstreams that are used for weather reconnaissance as well as training, and be flown and returned back to Houston's Ellington Field. The current target arrival for the crew members at Ellington is about 7 p.m. Central Time. That could and most likely will be adjusted depending on how long the medical checkups take and the departure time of the crew from Edwards. But the current planned schedule is for the crew to return to Ellington at about 7 p.m. this evening Central Time. We are also expecting with that call from Kurt Brown to the orbiter, turning the vehicle over from the Mission Control Center to the Lockheed Ground Control support people. The mission is officially complete in terms of mission control support. Post-landing press conference will follow. The time is to be determined at this point. The participants will be Leonard Nicholson, the Space Shuttle Program Manager, and also Mr. Walter Brunks, who is representing the STS-55 Space Lab D2 Mission Manager. STS-55 crew departing the orbiter Columbia on the way back for routine medical examinations before returning to Houston. Crew's scheduled arrival time at Ellington Field is around 7 o'clock this evening Central Time. That likely will be adjusted depending on the length of the medical checkups and the departure time from Edwards. The schedule for the post-landing press conference with Leonard Nicholson and Mr. Walter Brunks will tentatively be scheduled for 10:45 Central Time, 11:45 Eastern. That's a post-landing press conference originating in the Johnson Space Center. Shuttle Program Manager Leonard Nicholson and STS-55 Mission Manager Representative Walter Brunks. And again, that was scheduled tentatively for 10:45 this morning Central. With that, this concludes public affairs commentary of the STS-55 mission. Again, Columbia ending the mission with a landing at Edwards Air Force Base on runway 22 after completing 160 orbits of the Earth, traveling 4.1 million miles.
Good morning and welcome to the Johnson Space Center, the STS-55 post-landing press conference. We have two briefers with us today. First, we'll hear from Space Shuttle Program Manager Leonard Nicholson about the overall success of the mission and the status of the vehicle and crew. Then we'll hear from the D2 Mission Manager Representative, Walter Brungs. But for opening comments, I'll turn this over to Leonard.
Hey, good morning. It's certainly a pleasure to talk about the successful completion of such an outstanding flight. I've just talked to some of the folks out at Dryden, and they assure me the crew is in excellent shape, and they're going through some of the post-flight physical activities as we speak. The vehicle appears to be in really good shape. The complete walk-down's not been completed yet, but we don't have any issues that we know of that are to be worked. It appears to have come through the mission in absolutely outstanding condition. In addition to that, I would like to congratulate our German friends on the exceptional performance, not only of their hardware, but also their people during the flight, and also to express my appreciation to them for the patience and the cooperation they've demonstrated both in preparing for this mission and in executing it. It clearly has been an outstanding mission from the shuttle's point of view. I would also like to mention a fact that you all know that we experienced a few delays in getting the mission off, but I would remind you that the reaction of the team, not only to of the hardware, but also people, to those delays and the subsequent accomplishment of the missions of Discovery and Columbia in absolutely outstanding fashion, to me demonstrates clearly that the shuttle program can indeed support the nation's access to space requirement. We have also demonstrated once again, I believe, that the meticulous time that we take, work that we put into preparing the vehicles, the patience demonstrate when the hardware doesn't quite work right and we go chase those problems down, pays off in the long run. It pays off not only in the best on-time performance of any launch vehicle that we've had, but it also pays off in completion of our missions. We once again have extended a mission a day beyond the original plan, allowed us to achieve more science by that extension. And in the last 30 flights of the shuttle, we've only had one problem, which has caused us to talk about shorter missions instead of longer, while at the same time we've extended missions a total of 6 days. So the hardware is performing well. The work we're putting into it, the patience that you show and the team shows and make sure everything's right before launch is paying off. And I'm extremely proud to be a part of the team. So thank you. It's been a good day and a good mission, and we're extremely happy.
Mr. Brungs,
thank you. I would like to give a first resume on behalf of the German authorities and my mission manager. I would like to mention that this has been a highlight of German space activities. It really involved 7 years of hard work, and it came to a very successful end today. It was a very challenging, multidisciplinary, extensive space mission, and as far as we know, it was the most challenging one to date. It demonstrated the high professionalism of the people involved, the high performance of the people, and it also showed that an international endeavor of this size can work very well. So we have to thank all the international partners in the first place. We have to thank all people involved, the partners in science and technology, the industry, the crew, and especially our NASA friends. I might subdivide this into the STS people and the MOD people who worked hard to cope with any anomaly we had. And so we really come to an end of the mission, outstanding results. I heard my mission manager say in Germany, the science results are exceeding all expectations. We had an excellent crew. Columbia worked perfect, as did Space Lab. And so I only can report about happy faces in Germany, and it's time to celebrate this international endeavor. It also can be a model of cooperation for use of the space station, where more international cooperation in the science area is going to come about. And so far I can say all of us are very pleased. And concerning the science, I would like to say that also the last day gave us a lot of additional runs, a lot of improvements, and I would like to highlight especially the area of the human physiology being done in Interact. And I think everyone has seen our TV star Rotex, has seen the very nice pictures we got with our mom's camera of the Earth. And so altogether, I just can say we are very happy that we did it and that we accomplished it. And I have especially to thank NASA for their support. For without NASA support, it wouldn't have been possible.
Thank you, Mr. Brungs. With that, we'll begin taking questions here in Houston before we go on to the other centers.
Bill Nelson, Access for Springfield, WTX Radio. For Mr. Nixon, I'm wondering this time if you have any concerns and what concerns you have on what impact landing in California instead of Florida will have on the future schedule.
Yes, well, one of the things we do is we put some contingency time in our flows and our planning to cover this occasion. So we are about to look at the work for the next flow, and we think the next flow may have a little more work in it content-wise than we originally planned. So we may have to make some minor schedule adjustments, but this is not going to have any effect, significant effect on our year's plan at all.
Hi, Jake Dyer with the Houston Chronicle. I have a question for Mr. Brungs. Any word yet on things? First off, the fish. Have y'all been able to look in that? It might be a little early to ask that question, but to look there and to see how many survived. Also, there was some concern that with the landing at Edwards, that perhaps some of the anthorac or some of the physiology, the human experiments would be affected. What's the status on that?
Yeah, landing in Edwards had some impact maybe on the science, which I couldn't really put out in quantitative numbers. You are right, the post-mission